Welcome to this lecture on the collection of official statistics. Imagine trying to plan a massive family dinner for 1,000 people without knowing what anyone eats. You would be completely lost. Running a country is exactly like that, but on a much larger scale. Today, we are going to learn how governments gather the crucial facts and figures they need to make decisions that affect all of our lives. Now that we understand the basic premise, let us dive into what official statistics actually are. They are the numerical facts and figures collected by the government to understand the population, the economy, and society. Think of them as the nation's reality check. Without these numbers, the government would be flying blind. They would not know where to build new schools, where to send medical supplies, or how to plan the national budget. Gathering this information for millions of people is an incredibly difficult task. The government has to actively go out and collect this data using specific scientific methods, which we will explore next. To gather this massive amount of data, the first and most famous method used is the census. A census is a complete enumeration. This means the government attempts to count and collect data from every single person in the entire population. Think of it like checking every single grain of rice in a massive cooking pot to see if it is fully cooked. Because it tries to reach absolutely everyone, a census provides incredibly detailed information, even for the smallest villages and towns. However, because it is so massive, it requires millions of workers, takes years to plan, and costs a tremendous amount of money. Since a census is so expensive and slow, the second method is the sample survey. A sample survey is a method where the government collects data from only a small, carefully chosen fraction of the population and uses that fraction to represent the whole. Returning to our cooking analogy, this is like tasting just one spoonful of rice to determine if the entire pot is ready. Because you are only talking to a few thousand people instead of a billion, sample surveys are much faster and cheaper to conduct. The trade-off is that they cannot provide detailed data for a single tiny neighborhood. The third method relies on administrative records. These are data sets created as a byproduct of everyday government operations, rather than through a dedicated statistical survey. For example, when a baby is born, a birth certificate is issued. When someone earns a salary, they file a tax return. The government can simply gather these existing records to generate statistics. This is like looking at your family's past grocery receipts to figure out what they like to eat, instead of actively asking them. It is incredibly cheap and fast because the data is already sitting in a computer system. Now that we have seen the three methods, let us compare them side by side. First, looking at cost, a census is the most expensive, while a sample survey is moderately priced, and administrative records are the cheapest. Second, regarding accuracy, a census is highly accurate for small areas, but suffers from human errors due to tired workers. A sample survey has mathematical sampling errors but better quality control. Third, in terms of frequency, a census usually only happens every 10 years, whereas sample surveys can be done yearly and administrative records provide continuous data. Finally, their coverage varies from the entire population to very specific groups. Let us visualize how these methods work together. On the screen, you can see a flowchart representing the national statistical system. Notice how the census, the sample survey, and administrative records all have arrows pointing into one central database labeled official statistics. A smart government does not rely on just one method. Instead, it uses a combination of all three to balance cost, speed, and accuracy. By understanding the strengths and weaknesses of each, statisticians can choose the right tool for the right job to build a complete picture of the nation. Collecting the data from these sources is only the first half of the battle. In the real world, people make mistakes. They leave questions blank or misunderstand what is being asked. If the government publishes this raw, messy data, the resulting statistics will be completely wrong. Therefore, it must go through data validation. This relies on two techniques: editing and imputation. Editing finds and corrects obvious logical mistakes, like a 5-year-old listed as a medical doctor. Imputation fills in missing data using logical mathematical guesses based on the rest of the person's answers. Together, they ensure the final statistics are trustworthy. Even with perfect validation, a survey is useless if not enough people answer it. In official statistics, there is a strict golden rule. A survey must achieve at least an 80% response rate to be considered reliable. Why 80%? It comes from mathematical studies on a dangerous problem called non-response bias. This is the hidden error that occurs when the people who ignore the survey are fundamentally different from the people who answer it. For example, busy people might not answer a survey about free time. The 80% rule acts as a strict safety net against this bias. To enforce this golden rule, we need to calculate the response rate mathematically. This formula shows us exactly what percentage of our targeted sample actually completed the survey. In this equation, R represents the response rate, expressed as a percentage. The symbol N subscript R represents the number of respondents, which is the count of people who actually filled out the survey. The symbol N represents the total sample size, which is the total number of people who were originally asked to participate. By dividing the respondents by the total sample and multiplying by 100, we get our percentage. If R is less than 80, the survey is in danger. Let us see this formula in action with a concrete example. A government statistical agency is conducting a survey on household electricity usage. They mail out questionnaires to a total sample of 5,000 households. After a month of waiting, they receive properly filled out forms from 3,800 households. We need to calculate the response rate and determine if this survey meets the strict reliability threshold required for official statistics. We start by identifying our given values and stating the standard response rate formula. We know our total sample size N is 5,000 and our successful respondents N subscript R is 3,800. Continuing with our calculation, we substitute the known values into the formula. We replace N subscript R with 3,800 and N with 5,000. Dividing 3,800 by 5,000 gives us a decimal value of 0.76, which represents the proportion of people who answered. Finally, multiplying by 100 gives us a response rate of 76%. Because 76% is strictly less than the required 80% threshold, this survey fails the reliability test. The government agency cannot safely publish this data yet. They must either send out reminder letters to get more responses or apply complex statistical adjustments. Now that we know how to check the response rate, let us understand exactly how non-response bias destroys data accuracy when that rate is too low. This formula calculates the exact amount of error introduced. The symbol B represents the total non-response bias. W subscript M represents the proportion of missing people. The symbol Y bar subscript R is the average answer given by the people who responded. And Y bar subscript M is the true average of the people who went missing. As the proportion of missing people increases, it multiplies the difference between the two groups, causing the bias to grow rapidly. Let us apply this bias formula to a real-world scenario. A city conducts a survey to find the average monthly income of its residents. The people who actually respond report an average income of 50,000 rupees. However, the people who ignored the survey are mostly low-income workers who actually have an average income of 30,000 rupees. We are told that 30% of the total sample ignored the survey. We need to find the total non-response bias introduced into the city's data. We start by listing our known variables. The missing proportion is 0.30, the respondent average is 50,000, and the missing average is 30,000. Continuing our calculation, we substitute the known values into the bias equation. We calculate the difference inside the parentheses first. The difference in income between the people who answered and the people who ignored the survey is 20,000 rupees. Multiplying 20,000 by 0.30 gives a final bias of 6,000 rupees. This means that if the city publishes the raw survey data, they will accidentally overestimate the average income of their citizens by 6,000 rupees. This massive error perfectly illustrates why a 30% non-response rate is completely unacceptable in official statistics. We have covered a lot of ground today. Let us review the most important ideas. First, the collection of official statistics is the backbone of modern governance and economics, guiding everything from political boundaries to interest rates. Second, governments use a mix of censuses, sample surveys, and administrative records to balance cost, speed, and accuracy. Finally, raw data is never perfect. By strictly enforcing rules like data validation and the 80% response threshold, statisticians ensure that the numbers guiding our world actually reflect reality. You now understand the rigorous process behind the numbers that shape our society.